Question 6 is coming from differential equations. They are saying the variables x and theta satisfy the differential equation. This one here, where x and x is equal to 5 when theta is equal to 0. So the differential equation and obtain an expression for x in terms of theta. Now what we need to do here is to separate variables first. You put x on one side and theta on one side. So separating variables. When we separate the variables, you can divide all through and this one comes down here. Then this one can come up there. In other words, you can switch these two. The theta to go up here and then for this one to come this down here. So that means we are going to have something like this. Dx, then over 1 over 5 of x, then plus 1. And then this one is equal to sine squared 2 theta, then d theta. Okay, then the next thing is to integrate. Now integrating will give us the integral of 1 over 1 over 5 of x, then plus 1. The x here shall be equivalent to the integral of sine squared 2 theta with respect to theta. Now, for even powers of sine and cosine, we use the double angle formula for cosine. Okay, we know that cosine of 2 theta in terms of sine is 1 minus 2 sine squared theta. So meaning when you bring this one this side and take this one here, then after you divide by 2, so that means that sine squared theta is equal to a half of 1 minus cos 2 theta. Now this simply implies that sine squared 2 theta is going to, look at this, theta here, but here you have 2 theta. So if I have 2 theta here, I multiply it by 2 here, I will have what? 4 theta. So meaning we are going to have a half 1 minus cosine of 4 theta. Then we shall substitute here. And also, when you differentiate this one here, I can transform this one into the one that is up there. When I differentiate this 1 over 5 of x, then plus 1, I can get 1 over 5. Okay, I can get 1 over 5. Now I ask myself, what should I do to this 1 over 5 to get a 1 here? I will multiply it by what? By 5. So that operation you are putting here, that multiply it by 5, it is the one you are going to put on the natural log. Okay, in other words, we are going to have something like this, that 1 is the same as 5 times the derivative of what is down. You see, over 1 over 5 of x, then plus 1, then with respect to x. Because this side now I can put a half into 1 minus the cosine of 4 theta, then the theta. So you see, but we also, now I can take the 5 this side, outside. Now what is up is exactly the derivative of what is down. Then that one gives us a natural log. We know that when you integrate the function here, the numerator is the exact derivative of the denominator, then you will get the natural log of that function, maybe plus c. Okay, so that means here I'll have the 5, put this 5 outside. Okay, then natural log of 1 over 5 of x, then plus 1, then this one shall be equivalent to a half. I can put it outside. When you integrate 1 with respect to theta, you get theta. When you integrate cosine, you get a positive sign. So sine of 4 theta, but then this is 4 theta. So you differentiate this one, it will give you 4. Then for integration, we divide. For differentiation, we multiply. So this one will be over 4. Then I can put c. This constant of integration, you can put it on both sides. So plus a constant here, but then don't say plus c plus c, that means it is going to cancel. So you will put a constant here and a constant here, but then when you subtract these two constants, you still get a constant. So that constant, the constant that we put here, you can put it on the right or on the left. It is the difference between the two constants on the both sides. Okay. Now from here, we use the initial conditions given. They gave us for theta, which is equal to 0, then x is equal to 5. So put a 5 here, you will get a 1, then plus 2, that is a 2. So 5, then natural log of 2. And this one will be equal to, this one will be a 0. And then that is our c there. So meaning we are going to have 5, the natural log of 1 over 5 of x, then plus 1. This one is equivalent to a half of theta, then minus a quarter sine 4 theta, and then plus 5 natural log of 2. In differential equations, this is what we call the general solution. When you haven't found the arbitrary constant here, then after finding that constant, what you get here is what we call the particular solution. So that is the particular solution, but they told us to obtain an expression of x in terms of theta. So you have to make x the subject of the formula. Now what I'm going to do is to bring this one that has gotten the natural log this side, such that I simplify those logarithms. So we can have 5, and 5 will be common. So I can factorize it and say this is natural log of x over 5, then plus 1. Then there will be minus natural log of 2. Remember, this one has come this side, and I've factorized out the 5. Then this one will be a half into theta minus 1 over 4 sine of 4 theta. And this will be 5. And for subtraction of logarithms, we always divide the powers. So we shall have natural log here of now x over 5 plus 1, then we divide it by 2, then it's equal to a half, and then theta minus a quarter sine of 4 theta. Then I can proceed by taking this 5 away to this side. So when I divide all through by 5, I'll have natural log of this will be x, then over 5 plus 1 over 2. Then this one is going to be equal to 1 over 10, and then theta minus 1 over 4 sine of 4 theta. This one you can simplify it, or I can leave it. Then take away the natural log. We can have x over 5 plus 1 over 2 shall be equal to e to the power of 1 over 10, okay, into theta minus a quarter sine of 4 theta, okay. If you get a half, then divide by 5. This one is over 1, so it is the same as a half, then times 1 over 5. That is why we are having 1 over 10 here, okay. So that is that. Now we can multiply all through by 2. So when we multiply all through by 2, this one is going to give us x over 5 plus 1 is equal to 2 e to the power of 1 over 10 into theta minus a quarter sine 4 theta. And then take away the 1, you get x over 5 shall be equal to 2 e to the power of 1 over 10 theta minus a quarter sine of 4 theta, and then minus 1. Now multiply all through by 5. That means this one will become 10. Then e power 1 over 10 theta minus 1 over 4 sine 4 theta, and then this minus 1 times 5, so it will be minus 5. Or you would do like this and then you put the 5 there, no problem, it's all the same. So this is my answer here.